Hey everybody. So today we're going to be talking about mean absolute deviation. And our learning target is I can calculate the mean absolute deviation of a set of data. So this is one of the ways that we can use to compare data. We've been talking about comparing and analyzing data. And mean absolute deviation is one of the ways that we can do that. So to start it off, we're going to look at an example. So let's say that Blake surveyed two groups of people to discover the number of siblings that each group had. On his first group of people that he surveyed, the mean or the average number of siblings that they had was 2. And for the second group, the average was also 2. So in both groups, we had an average of 2 siblings. Now, our goal is to compare the two groups. So given this information, do we feel like the data was pretty much the same? Or do we feel like we need a little bit more information to make that decision? Right. So we're going to need to look at the data to be able to make that judgment. So if the data from the first group is presented and the data from the second group is presented, I have these two sets of data and they're looking pretty different to me. So even though they have the same mean, the data is much more spread out on the second group. So that's kind of what mean absolute deviation helps us do. Mean absolute deviation is the measure of how spread out data is in comparison to the mean of the set. So there are two examples here with the number of pets. So you'll see on that first one and on the second one, they have the same mean. The mean is 3.5 on both of them. But on that first one, it's kind of spread out a little bit more. It's covering a wider variety of numbers than it is on the second one. It's kind of all in the same general area. So with mean absolute deviation, we're just seeing how spread out it is in comparison to the mean. It's a measure of variation because it shows us how much the data varies. So if there's a lot of difference or if there's just a little bit, if it has a larger variety of data, then it's going to yield a higher mean absolute deviation. Whereas if it is just has a little bit of variety, there's not a whole lot of change between the numbers, then it's going to have a lower mean absolute deviation. So when we're comparing them, we can first put them on a dot plot to kind of get a visual representation of each. And just by looking at this dot plot, we can kind of tell which one varies more. We can see that the second group is much more spread out from the mean than the first group. So we know that since the second group is much more spread out, it will have a higher mean absolute deviation. But that doesn't help us actually find it. So we can look at them and we can see which one varies more. But if I want a number to make this kind of a concrete comparison, then I want to start by calculating that mean absolute deviation. So the first thing that we're going to do is find the mean of the set. So we'll start with the first group. So the set of numbers that we had was 1, 2, 3, 2, 1, 2, 3, 2. So we're going to find the mean by adding all of those numbers up. When we add those, we get a sum of 16. And then we know to finish out the mean, we have to do the sum divided by the total number of values within the set. And in this case, we have 8. So 16 divided by 8 gives me 2. So the mean is 2, which we knew that from the beginning anyway. But after that, we want to find the absolute distance. So I don't care which direction we're going, just like with absolute value, it's going to be positive because distance cannot be negative. So we find the absolute distance from the mean for each number. So if the mean is 2, we have 4 of these values on this dot plot that are at 2. So they are 0 distance away from the mean. And then we have a couple that are at 1, and then we have a couple that are at 3. So if we're comparing those, we only have a small amount of distance from the mean. So then our third step is going to be to add up all of those distances and then divide to get a mean of those distances. So we have 1 plus 1 plus 0 plus 0 plus 0 plus 0 plus 1 plus 1. All of those distances, when we add them together, we get 4. There were 8 total, so we do 4 divided by 8, and we get 0.5 as our mean absolute deviation. So 0.5 is relatively low. That shows me that there's not a whole lot of variation in this one. We want to do the same thing for the second group. So the first thing is to find the mean of our data by adding all of the values together. This time we still get 16. We divide by 8 since there are 8 values, and that gives us a mean of 2. But this time when we find the absolute distances, we see that they're a little bit more spread out. They're a little bit farther from the mean. So then my last step is to find the mean again, this time finding the mean of the distances. So we calculate each of those distances by counting them out. The distances are shown underneath step 3. So if we took time and we, counted all of those out and found those, then we would add them together. We get a sum of 18. Then 18 divided by 8, since there are 8 total values within the set, gives us a mean absolute deviation of 2.25, which is much greater than 0.05 on the other one, or 0.5, I'm sorry. So by comparing those, we can see that even though we could see it on the dot plot, we now have a value to make the comparison. So with our first group, there was only a variation of 0.5. The mean absolute deviation was 0.5. So that was lower because there is less variation. And with the second group, there was a whole lot more variation, a lot more variety of numbers. So we had a higher mean absolute deviation at 2.25.